So what I want to look at now is just a recap of what we saw in those simulations. So here's our formula, the standard deviation of the sample means. So remember, we call that the standard error of the mean, or we just say standard error. So you pretty much will only ever hear people say standard error. They'll never use that longer term. But what do we know it is? It's the standard deviation of that sampling distribution. What's the relationship? It's the population standard deviation divided by the square root of the sample size. So there I've got some examples. So if the population standard deviation was 20, we took a sample of 10, our standard deviation of the distribution of sample means would be 6.3. So what we're going to see now is an example of putting this in practice. So here's my example that I've got here. I've got my capital for coal mining company. Okay, so we might be either pro if you're Tony Abbott, or less enthusiastic about coal if you're anyone else. But here's my proposal. I've got a new coal mine coming up. Now, to build a coal mine, you need to get some capital. The reason you need to get some capital is generally you need to dig some dirt away. So I've got there my guys, we're going to clear the overburden from my mine, and then I'm going to have a nice pit of coal, and I'm going to truck it out to somewhere. I'm going to put it on a train, and then I'm going to ship it off somewhere. And this is going to be a very profitable business for me to be in. So to get this very profitable business up and running, I've got to go to the stock market, and I'm going to get an IPO, so an initial offer to generate some money from people to dig all this stuff out and build the infrastructure that I need. So you are aware that some of these things are quite controversial, and in the East Coast, we hear of billions of dollars being spent on building the required infrastructure. So you need to get the money to build the infrastructure from somewhere. So this prospectus that's out there, and it's trying to get money from people to invest in this coal mine, says, look, the reason that this coal mine is going to be profitable is that on average, we only have to clear away 50 meters of dirt, and then we can get to the coal and start shipping it and selling it. So if you give us some money, we can clear away this dirt, we can pay for that to go somewhere, then we can start digging out the coal, shipping it off and selling it. Okay, and so we're a bit skeptical about this, whether we want to invest or whether we're just skeptical about this coal mine in general, and so we want to test the claim on the prospectus, which is that we only have to dig away 50 meters worth of dirt to get to the coal. So what they've done is in their prospectus, which is a legally binding document, they put that out, and here's the distribution of sample measurements they've taken over the coal body. So what they've done is they've said we've gone and taken 100 samples over the coal body, and these are the, we had some grid that we set out, and these are the depth to the coal that we've found. So the mean is 52. Okay, so we're immediately on edge here and saying, hey, hang on, the mean of your sample is 52, and you're claiming in your prospectus that the mean amount of dirt that you have to move is only 50. So we're a bit suspicious about this coal mine, being proposed for. We may want to invest in it and make lots of money out of selling coal, or we may just not be very keen on coal and want to, really probe what these guys are doing. So the question we want to ask is, are they being legally true with us when they say, look, we think that the only amount of dirt that we have to clear over this ore body is 50, when we've got a mean from the samples that is 52. So this is what we have to think about. Okay, so we are interested in the population, so not just that sample of measurements, and for us the relevant population is the amount of dirt over the ore body. And so this sample gives us an estimate of the population mean and the population standard deviation. Now, if I looked at that, I would not be thinking that that's normal. Okay, so it kind of looks a bit skewed to me. There are some bits where it might be quite deep. Anyway, we don't care that it's not normal. So we don't care that the population that we've sampled from is not normal, because we've seen all those examples where we ignore the shape of the population, we still take a sample and we use that mapping rule to get our estimate of the standard deviation of the sample mean distribution, which we call the standard error. So we know that. So what's the rule that we're going to use? It's our estimate of the population standard deviation divided by the square root of the sample size. And we're just going to make it, we saw that we get different quality of estimates depending on the sample, and so we need to make a little adjustment for that. Now we saw when we looked at this earlier that by the time we had 25 samples, our estimate of the sample standard deviation was pretty good. So by the time we have 100, you can imagine that the adjustment that we need to make is actually very small. So what are the steps that we need to follow in our scientific process? So remember, we're actually interested in testing the claim by this mining company. So we need to set up a formal null hypothesis. The null hypothesis that we set up is that the mean is equal to 50 meters. The alternate, and this is what's going to be great for us, is this is the way we're going to frame all our alternate hypotheses, which is just that it's not equal to this. Now we might say, well, if it was less than, would we really care? Well, we're not going to, go down that path. We're just going to say the null is that it's equal to something, in this case 50 meters, and the alternate is always that it's not equal. We have this next step, which we always have to apply, which is the confidence interval that we set. So we're going to use alpha equals 0.05. Then we need to calculate the test statistic, if I could speak. So what's our test statistic? So let's have a look at the formula for calculating the t statistic. It's the sample mean minus the null hypothesis value standardized by the estimate of the standard error of the mean. So in compact notation, or because we like to be scientific, we might write this as x bar denoting the sample mean, minus mu 0, which is our null hypothesis value, divided by the standard error. So how do we interpret this test statistic? So if you just look at it, you can think that, well, if the sample mean is pretty close to the null hypothesis value, so that would mean that the numerator was small, that would probably mean that, the claim in the null hypothesis is maybe valid. All right, so if the difference between the sample mean and the null hypothesis value is small, the numerator is going to be small, and that's probably good evidence that, the null hypothesis is plausible. Now, if you think about a small numerator, it means that we're going to be close to 0. We could be positive or negative, but we're going to be close to 0. The other way to think about this is what's in the denominator. If that is large, so if we're very uncertain, so the sample distribution is very spread out, or we have a small sample, so if we have a small sample, we're going to have a large standard error. If that's very large, we're going to be very uncertain. If we're very uncertain, that's going to drive that whole expression of t close to 0. And in that case, we would not have insufficient evidence to reject the null. So you can see the two things that are going to drive our test statistic close to 0 are when the null hypothesis value is close to the sample mean and when the standard error is large. So when we have calculated our value, we can say that when the value is close to 0, could be positive, could be negative. When it's close to 0, we have insufficient evidence to reject the null. And when the test statistic is far from 0, we have sufficient evidence to reject the null. And the thing that I want to say here is the never say we accept the null. All right, it's either reject the null or do not reject the null. So that's what I've said. So let's be clear about this. When the sample mean is close to the null hypothesis value, we're going to be close to 0. When it's far, we're going to be far from 0. So when the uncertainty is high, when we've got a small sample, t is also going to be close to 0. So those are the things that are going to drive our t statistic close to 0. So let's have a look at this in a distributional sense. So what we've been saying is when t is close to 0, and this is what I've got here, that we haven't defined these critical values with a number, but when t is sufficiently close to 0, this is do not reject the null. When t is far from 0, that's this red area here and here, we're going to reject the null. All right, so this is our test statistic, the t statistic. When it's close to 0, do not reject the null. And we haven't got a fixed number here. I've just defined them as t and t minus or negative t. These are called critical values. And why I haven't defined them is that near and far from zero varies with sample size. So when we have a small sample size, a sample size of 5, here are the critical values for defining close and far to 0. And as we get up to 0, you can see that we get closer and closer to what is the normal distribution. So we have close and far from 0. And if you wanted to think about this in a rough and ready sense, as long as you've got a reasonable sample size, close and far seems to be defined by around about 2. All right, we can get a bit more exact from that, but if you're, doing rough and ready calculations in your head, rule of thumb, near and far defined by plus or minus 2 on the t-statistic critical scale. So what are going to be the steps in our process? So the first step in our process is we've got the sample mean, and we've got our sample standard deviation, and remember, they're our guess of the population standard deviation and the population mean. We then use our mapping rule to take this to getting a standard error for our sample mean distribution, and we have our null hypothesis value. So for us, the null hypothesis value is just the value that they used in their perspective. And we've got our formula here, sample mean divided by the null hypothesis value and divided by the standard error. So we get 0.81, okay, with some rounding. And we had a sample of 100. So you can see over here that this 0.81 is going to fall in the range of close to 0. So what we've got here is there's 0.81. That's our critical value, 1.98. So we say that this sample comes in the do not reject the null region. So what does that mean? It means that we have insufficient evidence to reject the claim made in the perspective. Now this t-statistic rule tends to be a bit hard to keep track of. I've said that if you think of 2 as a reasonable rule of thumb, that would work for you, but there's an easier way of doing that, and what we have is the p-value decision rule. So the p-value decision rule is easy. Whatever sample size we have, we can keep track of it by just looking at 0.05. So we're going to say whenever the p-value on our test statistic is less than 0.05, we would reject the null. Whenever our p-value is above 0.05, we would not reject the null. So I'm going to walk you through this test statistic. So I did this by hand, okay, and with reference to a t-table. With modern computers, we can use the p-value decision rule. So let's have a look at how we might actually implement this test. So the first step is we're pretty much always going to have our data in Excel. All right, so here's my original measurements, and I've requested from the company, for transparency reasons, that they make available their data. Okay, and they've done that, and they've said here are all the measurements, 1 to 100. Here are all the depths. So these are in the grid pattern that they put out over their claim. That's fine. So we go from Excel into R. So you can see here in my R Studio, what will I have done? I will have read in the data set. So there's the mine sample data set, and we can see over here, I've used the read CSV file, read in my mine sample, and a t-test is as simple as with the data set that I want to use, apply the t-test to the column in my data file called measurement and test against a sample mean of 50. Really for us, that's the critical step. Can we actually use the software to run this test? Then we just need to interpret the test results, okay? So here are my test results. I get, just like I got when I did this by hand, there's my t-statistic, 0.8. I have my p-value, 0.4. So we would say because the p-value is above 0.05, we do not reject the null, that the amount of dirt we have to move on average is 50. We might not like the coal mine, but we can't disprove the claim that these guys have made in their perspective. So what was their claim? Their claim was about how much dirt you would have to move to get to the coal. And that's going to be really important for the viability of a mine, because that's just money going out the door to move away all this dirt. You have to pay to move it and truck it away, so that's money going out without any revenue coming in. We formalized the test about their claim, which was this is a null. The null is that it's 50 meters of dirt that we have to dig on average. The alternate is that it's not 50. We conducted we set the alpha level, which was a critical value for making a decision, and then we just conducted the test. We looked at the output in R, which was really just saying, yes, we've got a p-value decision rule. We looked at that p-value. We realized that it was above 0.05, and we concluded that we have insufficient evidence to reject the null. So then we go on and say, the reason that we wanted to do this test was because we're interested in coal mining, and we may be motivated to make money from coal mining, or we may be motivated from a perspective that thinks that coal mining is maybe something that we should not be spending a lot more of our money and committing to. So if you want to get some more background on this, remember that there's a section in the chapter. So I've pulled out the section on the t-test, and I've got the little section here, but it's also in the book, and it's got all of the steps. It walks you through the steps that you need to follow. And so I strongly encourage you to read this and work through the examples in the book, and you'll be forced to read through the examples for the tutorial questions. And that's a really opportune time for a break. Thank you.